Hello everyone, this is Grade 6, Module 6, Lesson 19, Problem Set. When we look at Problem 1, college athletic programs are separated into divisions based on school size, available athletic scholarships, and other factors. A researcher wondered if members of swimming and diving programs in Division 1 tend to be taller than swimmers and divers in Division 3 programs. To begin the investigation, the researcher creates side-by-side box plots for the heights of 41 male swimmers and divers and of 10 male swimmers and divers at Eagle Crest College. So they have Division 1 and Division 3. And Division 1 is normally bigger, generally bigger schools than the Division 3. So I'm going to put those right there so we can see this. Which data set has the smaller range? Remember, range is the minimum and the maximum, and we find the difference of them. I can see that for this one, it's about 60, we'll say 6 to make it easy on ourselves, and it goes up to 80. So 66 and 80, I know that if I subtract those, I'm going to get 14. I'd subtract 80 and 66. Here I have about 65, and it's only going to maybe 74. And that's about 9. So I'm going to say which one has the smaller range. It's going to be Eagle Crest. B says true or false. A swimmer who had a height equal to the median for Mountain Vista University would be taller than the median height of swimmers and divers at Eagle Crest. So here is the median for Mountain Vista, and it said equal to the median would be taller than the median height of swimmers at the other one. So here's the median height here. And it looks like, yes, Mountain Vista median is bigger than Eagle Crest median. So that's true. And it's not asking us to explain, but we can see it inside of the box plot that the median of Mountain Vista is much higher, right around 73, and Eagle Crest is right around 68, we'll say, or 69. Now for C, to be thorough, the researcher will examine many other college sports programs to further investigate the claim that members of swimming and diving programs in Division 1 are generally taller than the swimmers and divers in Division 3. But given the graph above, in this initial stage of her research, do you think that the claim might be valid? I'm going to say yes, and I'll explain why. My thought is that 75% of Division 1 or Mountain Vista is about 71 or higher, and 3/4 or 75% of Eagle Crest are less than that same value of 71 or 72, whatever we say. So 75% of Mountain Vista swimmers and divers are much taller than I would say the 75% of Eagle Crest College. So at a given point, we can look at it and say that at 72, or so I'll put 71 there. I don't know the exact amount. But at 71, it looks like 75% of Mountain Vista is taller than that, and 75% of Eagle Crest are shorter than that. So let's go over to page 2. Here we are on page 2, and we have the data on the weights of 100 polar bears and 50 grizzly bears below. So we'll start with these, and we have some true-false. True or false, at least one of the polar bears weighed more than the heaviest grizzly bear. Explain how you know. Well, here's the heavy grizzliest bear, or the heaviest grizzly bear, sorry, not the grisliest bear. Probably is the grisliest bear if he's the heaviest. But we're at about 850. That's the heaviest. And it says at least one polar bear weighed more than that. Well, there's 75% of those polar bears, and they're much heavier than that grizzly bear, and I would say less than 25% of the polar bears are lighter than the heaviest grizzly bear. So I'm going to say this is true because more than 75% of polar bears weigh more than the heaviest grizzly bear. So there's my statement, and I'll put my true there, and I'll even circle it because I'm going to. Now for B, it says true or false, weight differs more from bear to bear for polar bears than for grizzly bears. So we don't have the data really to show every data point for the 100 polar bears and the 50 grizzly bears. That would help us quite a bit, but with our 5 points, we can kind of make an assumption on this. The first part is the distance between our 5 data points for polar bears are much more spread out than for the grizzly bear. So that's one piece. And then the other piece is if you look at the middle part of the data, the spread here, or the interquartile range, is roughly 180. And I'll put these marks. When I put these little wavy lines, it means roughly or approximately, because I don't know the exact values. Now, when we look up here for the polar bears, that's at about 1,000. This one's at about 1,300. So the IQR is roughly 300, meaning there's a greater distance on the interquartile range. So it looks like polar bear, this box plot, is much more spread out, and the grizzly bear is much more consistent or tight together, meaning there's not a lot of spread within the data. So there's my explanation right there, exactly what we talked about. And the last one, C, which type of bear tends to weigh more? I think you kind of know the answer to this one. Here is my 75% of the data for polar bears, and you can see that the 75% is higher than the heaviest grizzly bear. So here is about where the heaviest grizzly bear is. So more than 75% of the polar bears are heavier than the heaviest grizzly bear. So I'm going to put polar bears because of what I just said. And there's my explanation right there. So polar bears, because more than 75% of the polar bears are heavier than the heaviest grizzly bear. And yeah, little typo right in there. How about we call them grizzly bears instead of grizzle bears? So let's go on to page 3. And here we are on page 3. And we have a couple of box plots that we got to take a look at. So I'll summarize what this is. It is soon to be released movies. They had 300 people, and they were asked to rate the movie on a scale of 0 to 10. And there's the scale right there, with 10 representing the best movie I've ever seen. They asked 300 people, and this was just a new movie viewing. So here are some side-by-side. So they broke it down by women, what they voted between 0 and 10. And then they also broke it down by age groups. So we have our age groups in here. And I'll do these ones in blue because we'll have questions on these. So we're going to have to look at these too. So it was broken down 2 different ways. Women and men, and then by age. So A, does it appear that the men and women rated the film in a similar manner or in a very different manner? Write a few sentences to explain your answer using comparative information about the center and variability. So we're looking at men and women. So we want to look at this top one up here. When I take a look at this initially, I see that there is a difference here. I see that my minimum is 4 here, and my minimum is 5 here. So that's a difference. But if I really look at the data, it looks like they both had people who gave it a 10 as a max, This is interesting right here to me. The medians, just about perfectly lined up. The upper quartile, just about perfectly lined up, and the lower quartile, almost perfectly lined up. So I would say they rated this movie, men and women rated this film in a similar manner because 75% of them rated it a 7 or higher, with the median being the same, the upper quartile being the same, and the lower quartile being the same, and we could even say the upper extreme being the same. So I'm going to put that down below. So there's my explanation right there. And then for B, it says, it appears that the film tended to receive better ratings from the older members of the group. Write a few sentences using comparative measures of center and spread or aspects of graphical displays to justify this claim. So they're saying that older members of the group rated it better. And if we take a look here, we have our young population of 18 to 24, and we can see the center of the data is right here with a median right here. And we can see that with the 25 to 39 and with the 40 to 64, their 75% starts at 7. 75% for 18 to 24 starts at 6. The median of 18 to 24 is 7, where the median of the two older groups is at 8. We're not going to really talk much about the minimum because we see they match up here. The maximum is the same for the two age groups up here. Now, when we look at the piece of the data, so 75%, so I'm looking at this piece here, of, I'll say 25 to 64 age, and I'm doing that to encompass or bring in these two groups, rated 7 or higher. When I look up at the same point, the 7 or higher, we have 18 to 24 age 50% rated 7 or higher. So what this tells me is that people from 25 to 64 gave it higher ratings, not only because the max is up here, that could only be one person from each, but we're looking at the middle half of the data and where the middle part of the data is, as well as the percentages. So 75% rated it the same value as only 50% of the 18 to 24. So that's what I'd write down for my few sentences. Hope this helps. Thanks for watching, and good luck on the rest of your problem set.